You've heard space is a free playground, a boundless expanse where you can just float and go anywhere your heart desires, a cosmic ocean waiting to be explored. Myth: space isn't an ocean you swim through, it's a gravity dance floor, governed by a strict and unforgiving choreography. Every move is a calculated step in a ballet of celestial mechanics. The freedom we dream of isn't found by ignoring the rules, but by mastering them. Let's start with the biggest myth of all, that there's no gravity up there. There absolutely is. In fact, at the altitude of the International Space Station, Earth's gravity is still about 90% as strong as it is on the surface. The reason astronauts appear weightless is because they and their spacecraft are in a constant state of freefall. They are perpetually falling the Earth, moving so fast horizontally that they continuously miss the ground. That's what an orbit is, a fall that never ends. And no, you can't just point your ship at Mars and blast off in a straight line. That's the thinking that has kept us tethered to our pale blue dot. This approach is crushed by what we call the tyranny of the rocket equation. It's a cruel paradox. To go faster, you need more fuel. But that fuel has mass, so you need more fuel just to lift the fuel. It's a cycle of diminishing returns that makes brute force travel impossibly expensive. And you certainly can't hit light speed with a big enough engine. Physics sets the rules. It builds the walls of our cosmic prison, but it also provides the keys to our escape. So how do you travel in space freely? How do you move where you want, when you want, with the least amount of waste? How do we evolve from stargazers into star sailors? Here's the playbook I'd use, a step-by-step guide from our current reality to our interstellar destiny. Step 1. Master the fundamentals. Forget brute force. Think in terms of frames of reference, not muscles. In the vacuum of space, momentum is king. Once you're moving, you stay moving in a straight line forever, unless a force acts on you. That force is usually gravity, or a deliberate engine burn. Every action, to turn, to stop, to go, requires a precise application of force. We use small reaction control thrusters for orientation, and more efficient engines like electric propulsion for gentle, long-term acceleration. In this world, you must plan every single change in velocity. This is your delta V budget, and you must treat it like money. Every burn, every tiny adjustment costs you something. Waste it, and you'll end up stranded. Step 2. Ride the highways you can't see. Orbits are not just circles. They are invisible tracks, pathways of least resistance carved by gravity. We use maneuvers like Hohmann transfers, which are elliptical paths that let us move between two different circular orbits with just two small engine burns. It's the most fuel-efficient way to get from a low Earth orbit to a higher one, or even to travel from Earth's orbit to Mars's. For longer journeys, we can use bielliptic transfers, which take more time, but can save even more precious fuel. And for interstellar precursors, gravity assists let us fall smart instead of push hard. By flying close to a massive body like Jupiter, a spacecraft steals a tiny fraction of its orbital energy, slingshotting to higher speed with minimal propellant. If we time departures to align with orbital windows, when planets are in the right positions, we spend far less fuel and can travel much farther. Patience and timing are powerful engines. Step 3. Use gravity wells like cosmic skate parks. Imagine every planet and star creating a dip in the fabric of space-time. Dropping deeper into one of these gravity wells speeds a spacecraft up, converting potential energy into kinetic energy. Climbing out slows me down. This is the essence of the Oberth effect. An engine burn is most effective when you're already moving at your fastest, deep inside a gravity well. A small push there yields a massive change in your final trajectory. I'd skim past planets for these slingshots, trading a complex trajectory for time and speed, turning the universe's own structure into my accelerator. Step 4. Leave the fuel behind. To truly travel freely, we must break the tyranny of the rocket equation. This means embracing propulsion that doesn't require us to carry our own dead weight. Enter the solar sail. By deploying ultra-thin kilometer-scale sails, we can catch the momentum of photons from our sun. It's a gentle, continuous push. Concepts propose Earth-based laser arrays to drive these sails, potentially toward about 20% of light speed. At that velocity, Alpha Centauri would be roughly a 20-year trip, not counting acceleration and braking. For carrying entire colonies, we'll need the engines of the cosmos itself, nuclear fusion. By replicating the heart of a star inside a magnetic reactor, we can achieve millions of pounds of continuous thrust, a marathon of power that chemical rockets can only dream of. Even more powerful is antimatter. When matter and antimatter collide, most of their mass converts to energy. Practical engines face containment and efficiency limits, but a few grams could, in theory, power a fast sprint to our solar system's edge. Step 5. Break the cosmic speed limit. Even at light speed, the universe is vast. To travel freely, anywhere, anytime, we explore a theoretical loophole in Einstein's laws, the Alcubierre warp concept. Instead of moving a ship space, we move space the ship, by generating a ring that would compress space-time in front and expand it behind. A craft could ride a flat bubble. This remains speculative with unknown materials and energy requirements, and no experiment has demonstrated it. Step 6. Evolve beyond our biology. Space is hostile. To survive these journeys, our fragile human form must adapt. Future vessels will need artificial magnetospheres to shield us from cosmic radiation that shreds DNA. And for journeys spanning centuries, we must master synthetic hibernation, pausing our cellular aging. Passengers will close their eyes on Earth and open them, untouched by time, orbiting a new sun. But until that future arrives, we must respect our current limitations. Step 7. Stay tethered to safety. Outside a craft, I'd never just swim or float away. A single tiny push could send me drifting into the void with no way back. I'd use redundant tethers, always connected to the structure, and for untethered work, I'd rely on a safer backpack, a small jetpack with nitrogen thrusters. I'd use precise microbursts to translate and rotate, always keeping a calculated return path and a healthy fuel margin. In space, your lifeline isn't a rope, it's your delta V budget. Step 8. Let math do the heavy lifting. The dream of interstellar travel is built on a foundation of mathematics. I'd plot my initial course using patched conics, a method that simplifies complex multi-body problems into a series of two-body interactions. I'd use powerful software tools like GMAT and STK to run thousands of simulations, optimizing for fuel, time, and safety. Then, I'd constantly refine my path mid-course, making tiny corrections to account for solar wind, gravitational perturbations, and engine performance. In space, planning propulsion. So, want to actually go? Today, free travel means accessible travel, not zero cost. The journey begins with small steps. You can take suborbital rides for a few precious minutes of microgravity. Soon you'll be able to book orbital stays on commercial space stations. You can join analog missions on Earth, living and working in habitats that simulate life on Mars or the Moon. Or you can send a CubeSat into orbit as your own robotic self, a small emissary to the cosmos. The bottom line is this: freedom in space is an evolutionary process. It begins with mastering timing, efficiency, and respecting gravity's choreography. It progresses to harnessing new forms of energy, and it culminates in bending the very fabric of space-time to our will. From mastering the subatomic world of antimatter to bending the macroscopic fabric of the universe, our destiny lies out there. Learn the steps from the first to the last, and you, and all of humanity, can go almost anywhere. The universe is waiting.